I'd like to show you one example. Okay, let's say A is matrix 2 by 2. Okay, and B is matrix 2 by 3. Okay, before we perform the multiplication, we check the size first. So A is 2 by 2, B is 2 by 3. So the number of column equal to number of row. So we can perform the multiplication. Right. Okay, then we use the same technique I've shown before. Right, so we look at the first row of A. So this is the first row. Then we perform the multiplication with the first column first. Okay, first element is 4 times first element -1. Okay, second element is 2 times second element 2. Right, next we have settled for the first column. We go to the second column. Okay, first row with second column. Okay, 4 times -2. Okay, first element with first element plus 2 times 1. Second element with second element. So we have settled the second column. Then we have another column number 3. Okay, the pair is 4 and 1. So 4 times 1 plus 2 times 5. Second element. Now we have settled first row to all columns of B. Now we go to the next row. Okay, second row of A. Okay, with same technique. First element with first element 3 times -1. Then second element -1 with second element 2. Right, settle second row with first column. Now we go to the second column. Okay, second row, second column, 3 times -2 plus -1 times 1. Right. Okay, next second row with third column, 3 times 1 plus -1 times 5. Right. So find the answer. We have to calculate all the multiplication. So we have -4 plus 4, -3 minus 2, -8 plus 2, -6 minus 1, 4 plus 10, 3 minus 5. Okay, so we will get the final answer. -4 plus 4, 0, -3 minus 2, -5, -8 plus 2, -6, -1 minus 1, -7, 4 plus 10, 14, 3 minus 5, -2. So this is the answer. Right, so hopefully you will understand the technique, okay, to perform the multiplication. Right. Now we go to the final topic of the operation of matrices. Okay, so we have the conformable matrices. So what is conformable matrix? Okay, a matrix is confirmable if its dimensions are suitable for defining some operations. Okay? For example, addition, multiplication, and square. For example, conformable for addition if the sum of two matrices is defined, that is, they have the same order. That means if the matrix A and B, and we have two matrices same size, then the matrix is defined or can be performed to addition. So that is the conformable for addition. Okay, for conformable for multiplication, okay, multiplication of two matrices is defined into if and only if the number of columns of the left matrix is the same as the number of rows of the right matrix. Okay, this is the condition for matrix multiplication. That is, if A is n by n matrix and B is s by p matrix, then n need to be equal as to the matrix A B be fine. Okay, so A and B can perform the multiplication. So the condition is the size, the column of A equal to the row of B. And the last is conformable for squaring. Okay, squaring means A square equal to A multiplying with A. So squaring matrix involves multiplying by itself. So the size of matrix should be m by n. Okay, that is both matrix or A matrix A is a square matrix.